Alright, so this is the video for 6.5, and in this video we're talking about properties of logarithms. Okay, most of you will pick up on this pretty quickly, which is good. Some of you will struggle a little bit, but it'll eventually click, and it's not that bad. Okay, so before we even start, I want you to get with a shoulder partner. I want you to pause this video, and I want you to work through and talk about all of these and try to figure them out. Alright, so here are the answers to these now. I attacked mine more algebraically. A lot of you probably did this logically, which is perfectly fine. But you should have been able to reason through these, especially if you had a partner to think out loud and to bounce ideas off of. Alright, so the main part of this chapter is we are going to expand and condense logarithms, okay? So these are the three properties that you need to know when we expand and condense. Now, when we expand, okay, we're taking kind of a, I don't know, more complicated logarithm and we're breaking it apart into smaller components. And then when we condense it, we're taking a bunch of logarithms in smaller components and shoving it together to make one more complicated logarithm. You can think of it that way. Okay, but when we do that, we're going to use these three properties. Okay, so the product property is if we're multiplying two numbers, okay, we can separate them by adding. Okay, so just for clarity, okay, this would be the condensed form, and this here would be the expanded form. Okay, so condensed is all together, expanded is smaller components. Now, it'll get a little more messy than this, but overall, yes. Okay, quotient property, anytime we're dividing logs or we have a fraction, okay, we can simply break them apart and subtract them. Okay, and then if we're taking it to the power, notice that the power can now become an exponent. Okay, now these are very, very important depending on what you're trying to do. Sometimes we want just one big one. Sometimes we want several smaller components. Okay, so you'll do this a lot when you get into like pre-calc and calc, because how we write it determines how much we have to work. All right, so if we know here that log base 2 of 3 is approximately 1.585 and log base 2 of 7 is approximately 2.807, okay, we want to change all these into log base 3 and log base 2 of 3 and log base 2 of 7. Okay, so notice here we're dividing 3 and 7, or we have a fraction of 3 over 7, whichever way you want to look. Okay, so we will use the quotient property on this. Okay, so the quotient property tells me if we have a fraction, we can simply expand it by subtracting top over bottom, okay, numerator over denominator. And yes, it is important that it's numerator minus denominator, because we all know a minus b does not equal b minus a. So this could also be written as, using the quotient property, log 2 of 3 minus log 2 of 7. Okay, now it tells us that log 2 of 3 is about 1.585 and log base 2 of 7 is about 2.807. Okay, so if I subtract 1.585 minus 2.807, if I put it in my calculator right, that should give you about negative 1.222. Okay, let's do these two and then we'll talk about the answers here in a minute. Okay, so on B, okay, we have log base 2 of 21. Okay, now we want to break 21 down into 3 and 7 somehow, because that's the two things that we know. Well, a lot of you are probably thinking, well, 3 times 7 is 21, so we can rewrite this essentially as log base 2 of 3 times 7. Okay, all I did is I wrote this a little bit differently. 21 is equal to 3 times 7, so I can substitute them. Okay, and now I can see this as a product. Okay, so we could use the product property from up top. Okay, and notice the product property tells us if we're multiplying two numbers, when we expand them, we can simply add them. Okay, so that's what I'm going to do. So this is equal to log base 2 of 3 plus log base 2 of 7. Okay, well, now I do know what log base 2 of 3 is. It's about 1.585. And I know what log base 2 of 7 is. It's about 2.807. Okay, so if I find the sum of those two, and if I put it in my calculator correctly, this is roughly 4.392. Okay, now log base 2 of 49. Okay, I want to put this in log base 2 of 3 and or log base 2 of 7 somehow. Okay, well, a lot of you want to do log base 2 of 7 times 7, okay, which then would use the product property. Okay, and we can do that. That would just be the same as B. What I want to show you how to do, though, because we haven't done it yet, is to think of this as log base 2 of 7 squared. Okay, either one of these you'll get the same answer. It doesn't matter. Okay, so when we have a power, I guess this is the product property, and this is the power property. Okay, when we're using a power, notice that when we condense it, we can simply take the exponent and put it out front as a coefficient. So this is going to equal, okay, my exponent's 2, so it'll be 2 times log 2 of 7. Okay, well, I know what log 2 of 7 is. Okay, it's right here. So this would be about 2 times 2.807. Okay, and if I put that into my calculator correctly, that gives me roughly 5.614. Okay, now most of you are probably just going through the motions and finding an answer and are content. Okay, which is fine for now. But I do want to circle back and talk about what these mean. Okay, now remember, we haven't really gotten there yet, but we will very, very, very soon. We use logs to solve for exponents. Logs and exponents are inverses of each other. Okay, we can rewrite a log as an exponent, we can rewrite an exponent as a log. So if, for example, if I look at this, if I say that log base 2 of 3/7 is equal to, and I know it's about equal to, is about equal to negative 1.222. That's what I just showed. Okay, now let's put this back into something that's a little more familiar to us. Okay, if we write this as an exponent, okay, we would write it as 2 to the power of negative 1.222. That should equal 3/7. Okay, so I want you real quick, just so you don't call me a liar, I want you to put this into your calculator. Is 2 to the negative 1.222 power roughly 3/7? Okay, you should find that it is. Okay, same thing here. Is 2 to the 4.392, and remember these are rounded, so it'll be a little bit off. Is that about equal to 21? Okay, is 2 to the 5.614 power, is that about equal to 49? Okay, you should find that in fact, yes, that does work out. So you can always double check these if you'd like. All right, I would like you to go through and look at these on your own, okay? I would like you to do these 3 first, and if you do these 3, you don't need to do the monitoring progress unless you really, really want to, okay? But do these 3 first, pause this, do these 3 first. If you're having struggles, then do the monitoring progress as well. Okay, so this is what you should have gotten. Okay, and then once again, I do want to note, let's go back to what we're doing, don't lose track of that. Okay, this means that 3 to the roughly 2.93 power should be about 25. Okay, and all that works for all of these, okay? This one here, 6 to the 2.059 power roughly, these are rounded, is about 40.